Hey folks, welcome back to another video. Today we're looking at question 559, maximum depth of N-ary tree. N-ary tree basically means that a given node can have as many children as possible. It's not restricted to two trees, two children, like a binary tree. So what does the question ask? The question basically asks that the maximum depth in the number of nodes along the longest path from the root node down to the furthest node. That seems pretty simple, but we need to figure out whether the root is also counted as a node. In this case, this is the longest path, and the output here is 3, so the root is actually counted as 1, so 1, 2, 3. And in this particular case, it's 1, 2, 3, 4, 5, and that's the expected output. So it seems pretty simple. It's recursion. So let's get started. The first thing we need to do is we need some sort of like a global variable that keeps a track of like the maximum value that we've seen so far. We could do it as like global variable, or we could even pass that in like the recursive method. But for now, let's just have like a global variable. Within the main method, let's initialize the max to be equal to 0. We have some sort of recursive call, and let's just call it recursive for now. And then we need to give it two variables, right? We basically need to give it the node and what the current level it's at. So the current level that it starts at is 0. I wonder the total number of nodes are in the range of 0 to 10 to the power of 4. The depth of the N-ary tree is less than or equal to 1,000. So even here, we could potentially start with just 1, and only after we go to the next level, we can add like another 1 to it. But since we're starting both at bases, we could I'm going to make a choice to just start with 0 instead of 1, and we can account for that in the recursive method that we have. And in the end, once everything is said and done, all we need to do is return the max value. Right. So far so good. Right now we actually need to write the recursive method. The reason why it's not going to return anything is because if we wanted to return something, it would be the max value int, but since max is being tracked outside globally, we can just we don't have to return anything, so the type of the return value will be void, and the name of the method we have actually used recursive. Oh, the spelling is wrong, let's correct that. Recursive, okay. And we've taken two parameters, right? So node, and instead of calling it root, let's just call it current node, and the current level, right? So in this case, so you see that these values have a child can point to null as well, so let's just have that as a base function. So if the current node is equal to null, you would just return, so that actually is a good call out to start off with 0, because what if the root just points to a null value? So that covers the base case in this case, and the maximum in that case has been assigned to 0 and will return 0. So it's good that we start off with 0 instead of 1. And here, if it is not null, what do we do? And that means it has a level, and we increment, so it's gone to the next level, so we increment it by 1. And once we have that, let's check if this is a new max value or not. So that would be max of the current level and the maximum value that has been previously assigned. So this updates the max value if you've reached a new level that we haven't seen before. And we basically need to go through all of the children. So node, child node from all of the current node's children. basically what we need to do is call the method recursively on the child node. So that would be recursive child level. I think that's about it, and this keeps going till it reaches the very last node, and it will stop when all of the values point to null, and the max value will be returned. So let's try running this. The first few test cases are okay. Let's try submitting this. All the other test cases have been accepted as well. Amazing. So let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, where n being the number of nodes, because we have to go through each and every node that's given to us in the tree. The space complexity is O of n if we are considering the heap space for the recursive calls. If not, we're not really using any additional space. It'd be O of 1, depending on what the interviewer wants to hear. Right, so that's how we solve this problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon.